Join me, Harriet Gould, for the Lab Matters podcast to hear fascinating stories every week from the inspiring people behind the science. In this episode of Lab Matters with me, Harriet Gould, Silas Adekunle talks about education in Nigeria and puts the humanity into robotics and artificial intelligence. Today I am joined by Silas Adekunle, who is a Nigerian-British robotics engineer, inventor and entrepreneur. Silas, welcome to Lab Matters. Thanks for joining us.
Thank you for having me, Harriet.
Great pleasure. Now, we're going to go through some of the things. I mean, the thing that we're going to focus on is that what you're doing now, which is leading the charge on Lumi, which is a visual intelligence platform for science automation, which is very exciting. But of course, as usual, I want to hear a little bit more about your backstory. And you were born in Nigeria and came to the UK when you were 12. So let's go all the way back to then and tell us a little bit about life in Nigeria.
Yeah, sure. So I was born in Nigeria. I, looking back, consider my childhood to be so magical, just because I spent a lot of time in nature. So for context, my dad was a teacher, did chemistry, he did biochemistry. My mom was a medical nurse, and so I'd always been connected to the science world in one way or another, just as a path forward. But we lived in towns and cities. But we would also, my grandma lived in the village, and my dad had a small farm as well. So being quite connected to just going into the woods, birds, spiders. It was very, 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 very fascinating to me. And so I think that natural curiosity kind of developed at an early age, and that spanned throughout kind of my journey to my career at the moment. But yeah, that's the foundation that I started with. In Nigeria as well, the education system actually is really, really, really strong from a theoretical point of view. So, um, going through my academics, you get a really solid foundation in maths and sciences if you're kind of going in that direction. That actually, when I eventually did come to the UK, it took a while for the curriculum to catch up to what I kind of knew. Because in Nigeria, you can jump classes as long as you pass the test. But my
Fantastic.
dad always wanted to make sure that I had the social kind of, I stayed with kids that were my age as well. But maybe that's a bit of context of the background that I come from as well.
Yeah, certainly. I mean, it's kind of unheard of to be able to jump grades other than in really exceptional circumstances.
Mm,
But if that's the norm there, then
yeah.
you don't question it.
Yeah, you've also got the flip side where you can just repeat classes and you have teenagers, people with beards in, with just going at the level that's kind of appropriate for them. So the
Mm.
education system was strong on the theoretical side, but also had lots of flexibility to cater to the students if needed. Of course, in the wider context of Nigeria, then you can also think about access to education as a whole. But my parents really, really valued education and cared a lot about the sciences. Yeah.
Hmm. Now tell me, what was the reason that you moved to the UK?
So I guess for my parents, in pursuit of better outcomes, for themselves and for their kids. So there was a time when the UK had a shortage of nurses, and Nigeria being a Commonwealth country. So my mom started in midwifery, and then there was a call out, I think, to Commonwealth countries for nurses. And so as part of that scheme, she came initially, went into nursing, and then we joined her as well. I think it was I look back now as an adult, and for my parents with kind of young kids, I know it was really difficult for them. They had to have a period of kind of separation. My mom traveled, my dad stayed with us, and he was an educator, so they took really good care of us. But I always imagine like, wow, you have to be separated for like, 3 years just to kind of allow this to happen for us. But that's kind of the journey as well. We didn't come from a wealthy background and the context. My parents were hardworking class people who, so I know people across the full spectrum of
Hmm.
the different socioeconomic standards, of life. And I think that also helps you. I value that a lot, specifically when you're building technologies, because it allows you to relate to the people that are going to use this. It allows you to think of the impact you really want these technologies to have on society as well.
Mm, mm. I think, yeah, I think you're right. It's so important to, if you have that ex perspective in the first place, to
Mm.
translate it into what makes it relevant in what you're doing. Totally. So did you go straight to school then when you arrived
Um,
here? How did it
yes,
work?
yeah, I did. I mean, you move to an area and you have to apply and wait for the next academic years. I mean, it all seems so far away
I
now.
know. Sorry to drag you back there.
Yeah, no. It was also very, very exciting. I immediately joined the after school robotics club at the school that I went to. It was the first time I had access. So growing up, for example, I'd always take my sister's toys apart, put them back, stuff like that. I worked in a literal Radio Shack for a while, just as kind of like my part-time job. And then my dad was worried I'd be too interested in kind of making money. So it's like, okay, so stop doing that, get back to education. So when I moved to the UK, it was the first time there was a robotics club, and the goal was that if we did well, we would go to the US. So all of it suddenly just opened up a huge world of kind of opportunity for me as well. Um, some of the memories that were quite funny for me was, as any kid does, there are limitations. Well, not as any kid does. There were limitations on some of the computer systems. You couldn't access certain websites, and so I started learning to hack. How you could bypass, some of these. And I actually had a teacher that recognized that interest, and what he then did was, along with some other friends, he just allowed us to have access to a IT system that was off network, so that we could just play with it. And so these are some of the childhood memories that really stayed with me in terms of just some of the things that were so new and so fresh, and allowed me to develop some of my interests as well.
Mm. It's so interesting. You're the second person that I've spoken to recently who said they're essentially doing something slightly naughty, and the teacher captures that and sees it as a positive and channels that interest into something productive.
I think that's really important because, again, as for many children, and maybe because my parents had strong influences on me. They were philosophical. My dad was quite philosophical as well, and so um that it's always been fascinating how you teach someone, nature versus nurture was something we used to talk about kind of a lot. And in hindsight now, and myself also thinking about, family in the future and things like that, I look through because it was that teacher's approach. There was another teacher that actually said, like, this boy is a threat to society. Just because you're bypassing website limitations. And I think it does make a huge difference, how you nurture curiosity. I don't think anyone's inherently good or bad. It's kind of, okay, you've got this skill, you've got aptitude for it. Let's channel it the right way and help you, make sure you can do it safely. And I think that's really, really, really important in childhood development, as well.
I couldn't agree more. It would be nice to see consistency in that area, I think,
I
in
I I think
education.
so. Yeah, I agree with you.
Um, so you went ultimately education-wise to the University of Bristol?
Hmm. University of the West of
No,
England.
West,
Yeah,
sorry, yes, of course.
yeah. There are two
University of
universities
West
in
England.
Bristol, and
Yeah.
there's a bit of friendly banter and competition between the two universities. Technically, I also studied at the Bristol Robotics Lab, which was a joint effort between the two universities. So you're allowed, you can be forgiven, but because they're literally near the same space. And I did spend time on campus at University of Bristol as well. But the university I
And
went to was of the West of England.
and the University of Western England is in fact in Bristol. So.
Yeah, exactly. So yeah, I love Bristol. I only just moved from Bristol, but our offices and our lab spaces are still there.
Hmm. Mm. And how did you, because you graduated with first class honors.
Yes, I did, in robotics. And it was a great experience for me. robotics was quite new at the time. I think I entered uni at 2010. And I mentioned to you there was this common thread where taking toys apart, building robots, tweaking things. There was this field of robotics called Beam. Forgot the acronym now, but it was to do with mimicking, learning from nature and mimicking them. And so, after my GCSEs and A levels, I kind of just looked for the best university that was doing robotics. And Bristol had a robotics lab. I didn't even visit Bristol because I was living in Kent, in Gravesend. And Bristol was kind of like 3 hours away. I just saw they've got a robotics lab, they've got robots, let me apply. And Matt Studley, the professor who eventually was also the lead for robotics program, he was the one that probably read my application. He was very instrumental in my journey as well. But what fascinated me the most, immediately from the first year was the fact that it wasn't just about electronics and engineering. We were also asking deep questions around, what does it mean to simulate consciousness, to build this robot? Because at that time, one of the key projects that they had at Bristol Robotics Lab was mapping some of the neural networks in a shrew's brain. So they called it Shrewbot, I think, and they were using the whiskers as kind of sensory. And so the question Matt posed at the time was, if we mapped this robot one-to-one to a shrew's brain, and we gave it the ability to feel pain, is this robot really feeling pain or not? And suddenly that just opened up this wild world of kind of robotics and the craziness of it to me. So as you can see, I'm smiling. So the whole experience of robotics and building and all of the frontier technologies was just very fascinating. Really, really felt like we were at the forefront of what is obviously now a very, very important field. So many times spent just hacking and learning and playing about. It was a lot of fun.
I think it would give people a lot of comfort to learn actually that there was a lot of philosophical questioning going into the learning at the time.
I think so, but it depends on the person and on the people as well. And again, going back to educators, given that in my journey, actually, educate the right educator has made all the difference. I actually repeated a year because so I went to a grammar school after my graduation, but it wasn't a fit for me just socially. And instead, I would kind of be bunking off school just to learn Japanese because I wanted to by myself because I wanted to go to Japan to study robotics. And eventually, when I went to another school, the teacher there, he was just amazing at breaking down the concepts of maths that for some reason I couldn't get in another school. So it was always I'd always been quite observant of how educators also, approach their fields. And I think more than ever, it's really, really important for fields like robotics, like AI, for you to be considering fundamentally what this means, because I think you play an important role when you're building technologies. They ultimately shape societies, culture. By the end of the day, they're built by people for people, and we need to have everybody has a philosophy. You either recognize it or not, and it filters into what you build.
Mm, It's profound. Yeah, it really is. Um, so tell me, when you graduated with your first class honours, what was it clear what your next step was going to be?
Um, yeah, it was because so during my as you can maybe there's a pattern here that you'll be able to deduce, but I won't project. During my undergrad, the good thing about that as well was we had a placement year, and so I um I applied. I spent half a year at at Infineon Technologies actually, which was working on um certain types of chips, just microchips that they were designing, but it wasn't a fit for me. So it was actually the first time that halfway through a placement year, someone stopped and then went to another company. So I'd applied to Infineon and GE Aviation. Went to Infineon just because I thought I'd get exposure to chips, but it ended up being just purely kind of software. And I think for anyone that went into robotics and loves the integration of all of it, you can get bored quite fast. So it wasn't quite a fit for me. Then I went into I reached that back out to G Aviation. They were really, really happy to have me back halfway through the placement year. So I joined them, and I also realized it was kind of, you're going into big engineering and you've got all these project structures. So the key thing that my placement year did for me was just to help me realize, I like to be in the innovation field, to conceptualize stuff, bring them to market. And so it was during my placement year that I actually started my very first company, which was Reach Robotics. And the idea, that came out of that was the world's first gaming robots. But the backstory to that was immediately in the first year of university. So placement year is third year. First year of university, along with a bunch of friends. I told you we were hacking, stuff together. Um, I conceptualized this idea for using robotics kits to teach kids. And so we would go into schools, kids that were kind of like rough, use your robotics to kind of show them the same concepts that they were struggling to get. We're using this now, and they were really, really excited. Now you could learn to have robots kind of battle each other. And so I thought, okay, this could actually really be an amazing platform and a tool that captures people's imaginations, but also allows them to learn to code. And so by my third year, I thought this was a big enough idea. And that's how I found myself in the world of entrepreneurship and startups and venture capital and everything.
Hmm. It's such a delightful story, and it's so nice that you used your idea to help other people along the way as well. And 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 how practical, because it really gave it proof of concept.
Exactly. It's easier said than done, and there's so much more to entrepreneurship. I think over the time you mature from just going to build an amazing engineering product to okay, you have to take this to market, and you have to do all this learning alongside it, and the whole complexity that comes with that. But it's one big ball of fun, if I can say that.
Satisfying at least.
Yeah.
Um, so I'm not sure at what point Lumi came about,
Mm,
because it comes out of Reach Industries
yeah.
rather than Reach Robotics.
Mm. Yeah.
Um,
So I
yeah.
can tell you this the segue or the story that happened. So around in 2019, we decided because Reach Robotics, that company that was creating gaming robots, the education side was doing well, but it was actually slightly premature. Hardware and robotics goes through a cycle. We're in a cycle right now, but back then it, went up and then people realized the logistics, everything. So the education part was doing well. The Q4 heavy, consumer toy hardware sale wasn't doing as well. So we decided to wind it down, but the robotics products are still being used today for education. So really, really proud of that. So I took a break, traveled, did some wildlife photography, which is one of my hobbies. So that's what always, grinds me. I like going for walks in the woods. And then COVID happened. And
Were you in the UK at that point?
yeah, I was in the UK. So
And
COVID was 2020, right?
it was. And you were
Yeah.
your wildlife photography in the UK. So
No, no, no. I traveled. No,
okay.
so yeah, you need. We get lots of birds in the UK and deers,
Yeah.
and I
Otters.
like them. Yeah, all nature is beautiful. I like them a bit bigger, wilder. So I traveled around Africa, South Africa, Ethiopia, a few different places. Um, and then I came back early 2020. Myself and Chris, my co-founder, we started actually on an idea that was initially looking at robot teleoperation, but taking all of the learnings that we'd had from the previous business. So we started on robot teleoperation, and that evolved into capturing data in manufacturing systems and centralizing and visualizing that. Then COVID happened, and some friends in the life sciences space that were located to us wanted there were needs like lab continuity. How do we make sure things keep going? And we started realizing that a lot of the ultimately humans are our data capture ability because science is empirical. It's the one place where you do want to capture things exactly as they happen. And the complexity of the real world is, we humans, we're beautiful with our brains, with our ability to generate innovative ideas. But when it comes to actually capturing and digitizing this information in formats that you can then interact with them for downstream analysis, our subjectivity gets in. And I think that's a huge bottleneck that slows the pace of science down. And we realize ultimately, one key part of that bottleneck is the human eyes. Where you're capturing operational data all the time. And if you're tired, that has an effect. You forget something, that has an effect on it. And we'd been leveraging cameras before. Chris was doing his PhD in machine-human interactions in desktop scenarios. And that was a massive insight moment for us where at the end of the day, this is another layer of abstraction in terms of data capture and communication. And that's how Lumi and Reach Industries ultimately began.
Mm. So it's there effectively to smooth out that subjectivity that enters from humanity to
Yeah,
enhance humanity.
exactly. So one of the things that we aligned on right at the start was that, we build technologies to augment humans. I think even when you think of robotics as a field as a whole and they come in into society, you can get into the whole conversation around consciousness and entities and what they mean. But ultimately, in the same way that, AI, ChatGPT has been powerful in knowledge work, what we ended up building or with Lumi is essentially a visual AI co-pilot for science automation. That's applicable for scientists to just help you monitor stuff so you don't have to check on it 24/7. For a lab, it's about making sure you can standardize protocols, do better knowledge transfer, have reproducibility. And then as you get closer to quality control and manufacturing, you want to make sure that you actually have protocol adherence. You can do faster root cause analysis. The common thread across all of this is they all have operational data. They rely on the human eyes to capture massive amounts of data, and the inherently there's a bottleneck there. So that's this platform that we then set out to build.
Mm. And how's it how's it integrating so far?
Yeah, the journey has been exciting and interesting as well for myself. There's always a bit of learning when you're taking I'm a robotics engineer at heart, so I've had to learn a ton working with scientists. We built our engineering teams first, but it's always been grounded by actually the customer's pain points. So we first started out with working with a CRO, a contract research organization, and they do some CDMO work, so design and manufacturing, called Cat's Eye. So we went and approached them. We were introduced to the CEO, and they thought like, yeah, this is the next evolution of information layer in the sciences. And that was how we started. So essentially, I had a design partner to start with, learned, spent time in labs. I love visiting labs because you get to see the frontier of science. It's
Have you
actually
have you got a favorite one?
um Oh, they're all so interested in what they do because it's all about the technologies. I've been to AstraZeneca in Cambridge, all sorts. I've been to some of the biotechs in Boston as well. So they're all really interesting at the different. I've seen fully automated labs with just humans in the loop. I think the capabilities we have in science today are really amazing, and it's only going to get better within the next 10 years. Some of the things we'll be able to do will be much more exciting, and it's good to be a part of that wave as well that's driving that.
What do you think the some of the most obvious things are, I suppose, that are going to be able to be done because of this technology?
Yeah, so if we look at CGT, cell and gene therapy, for example, or moving towards personalized medicines, let's just take one of the whole process of discovery, medicines development, when you get to clinical trials. If it's personalized, you need to make sure that the sample tracking, you can't mix up, people's DNAs or some. And right now, mistakes still happens because humans are in the loop. Visual AI is going to be able to, it's eyes that can monitor stuff 24/7. They'll be able to track end to end. That's one of the trials we're doing with a large, global company right now as
Mhm.
well, actually. So that's one of the things that will be possible. Second is it's actually going to change the way we do science. I think, there is this. vision and dream of a complete, lights off, they call it lights off factory in automation, right? They don't need lights because robots can just work in the dark, right? It's going to take a long time for you to get that with science, maybe never, because you need that ingenuity. Science is both an art and a science because it's this creativity, creativity in it. But one of the things we started realizing was visual intelligence is not just about organizing information. It's also about how you interact with the real world. It's a critical substrate for physical intelligence. And we were having conversations in the lab, and I posted one of our scientists. I don't know. Have you watched Iron Man?
I
Like
haven't, no.
you haven't? All right, okay, never mind. But in Iron Man,
I might not be the only one.
yeah, okay. So there's a robot. So a guy called Tony Stark goes into a lab. It's got a robot called Jarvis, which is kind of like this AI that's just intelligent in the room, and it can move robot arms and stuff. So I just asked him if you could have a robot that just understood your protocols, understood your workflows, could see the stuff that you're doing. It's not just a body that you can rely on. And you say, "Oh, this for me, stir this for me while I do this." Parallelizing your workflow, that intelligence is going to be available to everybody, where it's going to change the space. You have a cobot that can work with you, on your bench top as well, and just augment you. So I think we're going to see a resurgence because so far the robots are the robotic systems that we had before were heavily kind of controlled. So they were more programmatic. You had to move out of their way because otherwise they could break your arm, things like that. We started putting force control in there, adaptive feedback. So at least if they touch someone, they'll slow down. But that's not enough. They still can't adapt to you or your workflow. But as they start to see, we've got the intelligence layer already. We've got lots of AI, strong AI capabilities. As you start to now take real-time data and allow them to process that, it changes how they can support you as an individual. And I think that's what it will allow. It will allow you to not just optimize labs or factories, but actually augment the work that people do on an
Mm.
individual basis. One scientist is going to be able to do the work of four people, and that's obviously going to ultimately accelerate. It's not just about medicines, sciences and everything, and our food and our materials, but it's also my hope will provide the opportunity to level the playing field as well in terms of access. You don't need to have huge access to lots of capital to be able to get a breakthrough out as well.
Mm. It's such an interesting paradox, philosophically almost.
Hmm.
The idea of because I like to enhance individuality and
Hmm.
encourage individuality and support it. And this way, it's almost standardizing something in order to further enhance that individuality. I think that's quite an interesting angle to take.
Hmm.
I wonder
Hmm.
if you would mind talking a little bit about what you think the perceived risks might be, because I'm sure some people might think that there are risks, and it would be nice to hear you. It would be nice to hear you address them.
Absolutely, of course, there are risks. If you're when you're developing, these new technologies. First of all, is you don't know what you don't know. We're starting to see that with some of these AI systems, how much they end up costing, environmental impact. Some of those. So I'm just talking about risks as a whole. From when it comes to, let's just talk about the field of visual intelligence as
Mm,
a whole, right? Um, as you start to embed that you capture valuable data, but you also have to educate people and keep privacy right at the center and the core of what you're doing. So you don't get a big brother effect, right? Our focus has really been on how can Lumi understand what the scientist cares about. I want to track this sample, I want to track this view. We then started moving on to how workflows happen. What are people's hands doing so that you can then, give that feedback kind of in real time. So I think that's one of them, which is how do you ensure that people have power, that whoever is the user of the technology has power over their data and they have an understanding. So I was on the board of a project a while back that the UK government was interested in. How do you do verifiable autonomy? So AI was kind of just black box. But how do you make it so that it's traceable, so that you have a decision tree that you can interrogate for every action decision that was kind of taken? And so that was one of the things that, again, going back to that thing that you mentioned, the philosophical side of it, when you think ahead of time, I can tell you what I'm thinking about. I think I can as a human. I can say to you, this is why I made my decision and this is why I did it this way. You never want to have that. You never not want to have that, especially in a field such as science. And one of the things, for example, is if you look at the generative AI field, we know that they can hallucinate a lot. It's dangerous to apply generative AI in the context of real-time science. Actually, you don't want to hallucinate results. Generative AI, large language models are a bridge to the human mind, how we communicate in a way. They allow you to contextualize information. But for real-time scientific workflows that need to be grounded in reality, visual AI systems are going to be the bridge to the real world, but you can't apply the same types of architectures that have been used for generative AI, where they just take in lots of data and then work in a probabilistic way. You actually need to use classical statistical ways to do it. So the risk area is making sure that technologies are built in ways that take in the need and the demands of the users and the industries so that you don't lay foundations where the world invests billions in it and it's not fit for purpose.
Mm.
Um, there are so many other risks you can talk about, but that's a big one I can kind of give you in terms of just the general strategy and direction that we're thinking
Mm.
about.
And I think it's a very practical one. I think that was a great choice.
Mhm.
We don't have much time left, so let's think about how to conclude. I think I'll ask you this question: um, if you could change one thing, either about what you're doing now or about the whole of the scientific arena, what would it be?
You know what? I think I wear multiple hats. So, obvious one that comes to my mind is, I do some work in Nigeria as well. I run a company there called Awari, and really Awari's goal, just because I exist, with Reach Industries, we're doing work at the very, very frontier. And then Awari has been a social enterprise that's been doing a lot of work in education initially, getting robotics kits into Africa, making sure kids are prepared for the future of work. Then when the AI boom happened, we realized, wow, there's such a gap. First of all, data sets from global South countries, so not just Africa, they're not even digitized, which means generative AI, can't have applications there. And so we started solving that problem, capturing data on a language data on a large scale, just so that you can have that representation. But this challenge or this problem is in every field. So, and I think for Africa especially, in terms of what Africa as an ecosystem, and I generalize on purpose, can offer to the world from a biodiversity point of view, from a natural resources point of view, from an insights point of view, I think the more we as a global community allow critical infrastructures, societal infrastructure like the sciences to be developed in those spaces, things are going to emerge that benefit all of humanity. So it's developing these critical technology infrastructures in other fields, in other areas, I think are really, really important. So that would just be my advocacy. If I could snap my finger, there would be more labs, in Africa, more educational infrastructure for some of these frontier technologies as well.
Brilliant. I think I can get behind that one. Silas, I'm going to leave it there. Thank you so much for joining us today. And you're going to be at Lab Innovations in October.
Yes, I'm going to be there. Thank you for inviting me. I look forward to learning from everyone that's going to come and speak and also sharing some of my thoughts as well. Yeah.
We'll look forward to it. Thank you very much.
Thank you, Harriet. I appreciate it.
Did you enjoy that episode of Lab Matters? If you did, please do send it to the people that you think will enjoy it the most.